Thumbs up, right on. Got OK signs in the back. All right. My first time speaking to the group, our organization's first time participating with the iRODS organization. We're glad to be joining as a member of the consortium. And you've had, as noted here, a lot of history working with other storage vendors. So the thing I think that should be taken as a positive for the iRODS consortium is your profile is growing, as was noted in the morning session, around the amount of funding that's necessary for iRODS to be able to do what it does. The amount of publicly cited funding is going down because the corporate side is stepping up. That's what we're doing, and that's what others have done, which is supportive of the organization. It means that you're getting greater reach, which means we're very excited to be a part of your story. Part of that means, from a storage perspective, and I was having this conversation with the gentleman we celebrated over lunch, Regan, I was talking with that fine individual for about 2 hours last night. No kidding, he consumed a lot of time and has a lot of things to say that are about half the time well ahead of where I am capable of. So all that is absolutely true. That was said over lunch. The man's phenomenal. So thank you very much for that conversation last night as I speak about you. One of the things that you mentioned though was, in the world that we live in and care about, that is storage, one of the fascinating things that occurs is we're passionate about it, whereas most of the world doesn't really know that there's something to be passionate about when it comes to storage. So why does it catch our attention? Why is it important to us? Those are the things that I care about. And for me, it was about my transition from sand to NAS. I started out as a sand bigot. I was very much about the, except I approached it from a media and entertainment perspective, not a classic virtualization use case. My perspective was about performance. And the thing that I could get out of SAN was absolutely performance. But the thing I could not get was ease of management and scale. It does not. And that continues to be the pain point that people express since I started first working with SAN 15 years ago. So I drank the scale-out NAS Kool-Aid when I first got exposed to Scylla in 2006. That product really talked to me. There were two technologies I got exposed to, that and Lure. The whole aspect around ASICs and what's powerful about that for protocols. Yeah, that's great, you're building hardware specific to solve a problem. The future is software. And that's what I still opened my eyes to do, which is to get out of this hardware-bound world and let software do what it can do best, which is be flexible and agile. So when I look at storage, one of the things that constantly comes up when I talk with people is this aspect, which is, I look at the world through a metaphor. After I drank that Iceland Kool-Aid, the concept of scale-out NAS came to me as, there's got to be an easier way to manage data. And ultimately what came down to the equation is, there's a variety of ways that you can manage data today through storage platforms. There's commercial products and there's open source products. Ultimately, there's a trade-off involved. You can see this is the classic one. For those of you not familiar with this, if you're in the European theater, you may not be familiar with this phrase. It gets used a lot in the United States. Pick two is what it comes down to. What I would suggest to you is, it's the wrong way to look at this thing we're passionate about, which is important to data, which is the way it's stored. What I would suggest is more important instead is to look at it this way. Because the quality of what you put into your work matters. The quality that you take care for it, curate it, matters. So using the word cheap, this very flippant way that the United States viewpoint person thinks about trying to find an affordable way to deal with this, is the wrong way to look at it. Instead, you can gain a benefit that's easy. And that becomes the thing that allows you to say, you can get all three. You don't have to give something up in the process. And with software-driven topologies, that's what's possible. That's what gets out of this hardware-bound world, the world of SAN that I came from. And then once I drank scale out, it feels like this is the future. So what I'd like to suggest is, I'm going to talk about the lens I look at storage through a life science perspective, because I was on the Iceland storage side, worked for that organization for about 5 years, pre-acquisition, EMC, and then post-acquisition. I was in the office of the CTO. I had to represent this product to a lot of customers, and I helped convince a lot of people to buy that product and invest in it, especially in the life science community. But the thing that's occurred is life science is outpacing the ability of that product to keep up with the pace of data being created. At the BioIT show in April over in Boston, every presenter that had a technology had to show this data point. So we all did. It's all about how the cost of genomic sequencing is going down rapidly, the amount of it being created is going up rapidly, and I augmented this slide because of what emerged last week, HPG write. So now we're going to add a whole new aspect of scale to the life science data creation space, which is we're going to make data, not scan it on the read side, but actually write it and do synthetic sequencing as an exploratory process. We'll set aside the interesting ethical discussions around that and go, we're moving in this direction. People are very compelled to do this for life science discovery sides. And if you're going to show this data point, you got to show these data points. So this is all about how the volume of data, and we know this as a business, impacts our ability to track and manage it. This was the very thing that Regan and I were talking about last night. The ability for humans to stay in front of this for metadata tagging purposes is approaching the impossibility of the human brain's ability to just comprehend the vastness of the data that must be applied as descriptors to this. There are better ways to leverage the approach toward metadata and storage because the way that the data is being created is far outpacing the ability for us synthetic human beings to be able to keep up with tagging it appropriately. As was mentioned yesterday, the way I use a word or phrase to describe something here in the United States may not be the way that it is described in the Netherlands. And therefore you have to incorporate alternative geos and regional tags that are the way they describe the same object that I have. Which means I'm exponentially dealing with that situation going on as well. As we share data across geographies, this is an even bigger challenge. So what does good, fast, and easy look like as a storage perspective? So to me, it's about true scale out. Scale out can apply to a lot of things. Scale out object, scale out block, scale out file. These are, I can use these terms in this room because we're all storage heads. Anything else outside of this and get into marketing with scale out block, I understand what is that. Your virtualization platform. Okay, yeah, I get that storage. It's Flash, right? It's all Flash. The whole world's going to Flash. Well, interesting marketing to say that, but ultimately there's these things that you need to get out of your storage platform, whatever its basis. Ensure to be true scale out, which means there's no single point of failure and all the components scale in some elegant, linear fashion. iRODS supports parallelism. Other platforms should support parallelism. Cluster technologies are ideally suited to parallelism, and performance comes from direct parallel access. You're distributing the job, and it should be very simple to manage. This is an interesting dynamic. I believe that any business in the process of making a widget, whether it's a discovery or something that is made available in the marketplace through open source or through commercial means, you should focus on that. You should not be incredibly talented at storage. If you are, start a storage company. Otherwise, your business is not storage. Your business is making, discovering, or solving problems in the marketplace, and storage is just a mechanism to that end. So, storage should be very simple to manage. If you're spending a lot of time managing storage, something's not correct. The business is investing time in a resource or multiple resources, people, to manage storage. You're supposed to be trying to discover breakthroughs in leukemia, cancer, and other things in the life sciences space. So managing storage does not help that. Storage should be invisible to that process. My favorite customer example is one of our favorite customers down in Australia, and it's the Garvan Institute. One of the things that they do is being able to focus on translating technical advances in cancer risk assessment, diagnosing children with intellectual disabilities. This is something that's personally important to me. I have a relative in my family that has this challenge. So I love supporting their ability to research this and share this knowledge with others throughout the world about how to help diagnose this more early. And what was interesting about this is the aspect of the new HPG write concept is around being able to possibly influence, once diagnosed, the ability to treat this at an early state in children. It's a very fascinating discovery. Who does not know what that is? Anybody? All right, good. I got a whole bunch of people here who know exactly what a high-C X-Temp is. We know how it changed everything, so I don't need to go through the particulars, except in the Garvin case study here. They were one of the first 3 institutes in the world to get it. So, knowing that for them, they went from 10 scientists to 80 as soon as their grant allowed them to get this device, they just got 1. The process resulted in a very interesting challenge here. Their grants, this varies region to region, it covers hardware, not personnel. So they were not given the ability to have more staff on the storage side support this new device and the amount of data it created when they brought it in for their increased amount of scientists to do research with it. This was their workflow, and the process of this workflow is still heavily used. It's heavily used today. And the main thing to focus on is this step right here, steps 3 through 5. So in the workflows where performance matters, once the data comes from the high-seq, you gotta throw it at a farm and be able to process it. This is a very generic step in life sciences. And while you can take this data and you can land this step out of the high-seq as HGST is illustrating, you can do this as an S3 potential process in the future, not yet. So this could end up being a cloud-based process. But for now, our performance best is an on-premise step. The way that most scale-out NAS can service a Linux farm, which is over 98% of compute in all of life sciences, is to be able to move the data into the farm where it's locally post-processed and then sent back with the result. So 2 weeks ago, I was over at Vancouver in British Columbia, and the British Columbia's Genomic Sequence Center has about 10 petabytes of this, and this is exactly what they do, this round trip. That's what Garvin used to do. Until they brought us in, you notice the number of steps just cut in half. So we exist in the marketplace because this is what Panasas does. And oh, by the way, we are easy to manage. Thing that happens if you look back into the history of Panasas, so it's Pittsburgh area network attached storage and software. That's what the acronym stands for. You didn't already know that. This company was started in 2000, and sometime around 2005 or so, there was a conversation between our chief scientist and another individual with Los Alamos National Labs, and out of that conversation came 2 directions on storage. One was scale, be fast and easy, and the other one was scale and be as fast as possible. And in the process, who cares about easy? That product is called Bluster. So directionally in the marketplace, there are 2 ways you could go. For extreme performance, but it's hard, or really good performance, and it's easy. I'm of the philosophy that easy is what matters, and throwing a lot of resources at maintaining a very fast storage product that requires a lot of care and feeding to keep it working, there's only a certain number of facilities that could do that. Our energy department in the United States has 8 facilities that do a lot of work with Bluster. That's great, but there's only 8 of those in the world, in the United States. Most other places need something that's a lot easier to manage. So for Garvin Institute, my favorite quote here is, we solve these business challenges for them. Because we eliminated the steps of having to round trip the data into the Linux farm and then send it back, because we have a direct flow protocol, it's analogous to PNFS. Panasas was actually part of the 2007 effort to bring PNFS to the marketplace through Red Hat and other Linux instances. However, our direct flow does all kinds of extra good stuff. And in the process of doing that extra good stuff, we think it's a distinctive solution in the marketplace. We increased their sequencing to their compute farm by 50x. They said the aspect of taking out the round trip and making the storage easy, they don't have a storage admin. Dr. Kaplan administers this. He's a PhD, but he's not a storage person. He administers Panasas because it's easy. That's what I think is the ideal situation for approaching technology is you shouldn't have to invest a lot of resources to manage it. The why? This is the world I came from. This is the world I still am a big fan of today. Can't help it, I really like the Iceland platform. I think it's a really cool thing. Except there's one thing it doesn't do that I wish it did. You talk to it through NFS or SMB, the file protocols. We heard earlier from the HGST presenter from Elliot that one of the aspects that's a concern when you use object, imagine object is here, is most of the applications are still file. So you either got to talk through gateway heads or other components to be able to reach the object back end, or you can just use a native file-based system that is clustered and scaled out, and natively supports these protocols and does it in a distributed fashion. So you can talk into any one of the nodes to be able to communicate into the platform. Storage generally also does the calculation of your data protection. Object does this as well if it's software-based error correction, forward error correction. So Reed Solomon or other algorithms do these things. The problem is you get hotspots because that's not a clustered architecture from an idle perspective. What Panasas does is two things different. We calculate parity on the client. Storage does not do that. And you talk to all the nodes from the client like a classic parallel I/O transaction, similar to what iRODS does. Except we do that at scale. So the combination of the two differentiates us from a classic scale-out NAS in that we offset the parity calculation from storage, put it on the client, and we parallelize it. I'm going to move forward to get to a really cool section of slides because I'm getting near my end point. Because I want to talk about the part that's really important and interesting, which is this. Part of our joining the consortium is we wanted to reach out to our hard drive supplier, HGST. They're our technology partner. What we want to do is solve a challenge that's a little bit outside of our sweet spot, and that's the ability to be able to use a large repository. You saw the presentation earlier today about that large repository. So the goal that we're trying to accomplish here is to leverage the iRODS relationship to partner with our friends at HGST to create an architecture that connects the two of them together. Ultimately, what we'd like to do is take the life science data assets and have them managed by iRODS. This is where the reading conversation with metadata gets really interesting, because connecting our Panasas storage to the active archive from HGST, as we saw earlier, that platform has incredible scale and regional reach. It can go multi-geo. What we'd like to do ultimately is leverage the work that's going on with our friends at Illumina that make the data, park ourselves in the middle so that data can come out as it presently does today from the high seek directly into Panasas for post-scan processing, or it can be staged inside of the active archive, and that staging could also be replicated or distributed across geos, managed by iRODS, to be able to either move data to us here or to another location. This cloud representation could be Amazon space, it could be another life science research center or facility. And ultimately, our goals by partnering with iRODS, because we're very new into the organization here, there's three main things we're looking to objectively accomplish here. We want to develop, because you have a storage resource plugin capability, we have a direct flow protocol. We want to develop a plugin that talks to our protocol that can be directed by iRODS to be able to do high throughput data movement via iRODS servers today, coordinate the data awareness with the HGST partnership, and ultimately support iRODS 4.3 efforts to step out of the data path. So with 1 minute left, to be respectful of everybody's time, questions and thoughts? Otherwise, with that, I'm really glad to announce we're here. We're early days. I know there's a lot of incredibly talented individuals here that do a lot of code level work. I represent product management at my company, Panasas. I've been here for a little over a year, and we're actively interested in helping drive the initiatives that you've all accomplished, especially you, Regan, over 20 years, with this product and this platform, and drive it forward with greater strength and build the awareness in the marketplace.